Imagine a force so powerful it can level cities in a blink, entire landscapes transformed into wastelands, buildings reduced to rubble, and lives irrevocably altered in an instant. A force that can poison the air, the water, the very earth itself. The aftermath lingers, with radiation seeping into the environment, making it uninhabitable for generations. This is the reality of nuclear weapons. Their sheer destructive power is a testament to human ingenuity and a stark reminder of our capacity for devastation. These weapons are not mere tools of war. They are symbols of ultimate power, capable of dictating the fate of nations and the course of history. They represent a fundamental shift in our relationship with power. The nuclear arms race redefined global politics, creating a delicate balance of terror. Understanding how they work is not just about physics or history. It's about grasping the monumental responsibility that comes with wielding such power. It's about understanding the profound responsibility that comes with such knowledge. The ethical implications are vast, affecting decisions at the highest levels of government and science. In this essay, we'll delve into the heart of the atom to understand the science behind nuclear weapons. We'll explore the intricate processes that release such immense energy. We'll trace their historical development, from the race to build the first bomb to the terrifying standoff of the Cold War. Each milestone marked by breakthroughs and moral quandaries. Most importantly, we'll confront the ethical dilemmas posed by these weapons. The debates that rage on about their necessity, their morality, and their future. We'll explore the lasting impact they've had on our world and the challenges we face in ensuring a future free from their threat. From disarmament treaties to the ongoing efforts of activists, the journey towards a safer world continues. To understand nuclear weapons, we must first journey into the heart of matter, to the realm of atoms. Atoms are the fundamental building blocks of everything we see and touch. Imagine an atom as a tiny solar system. At its center lies the nucleus, containing protons and neutrons. Protons carry a positive charge, while neutrons have no charge. Orbiting the nucleus are electrons, tiny particles with a negative charge. The number of protons determines the element. For instance, an atom with 1 proton is hydrogen, while an atom with 6 protons is carbon. The nucleus, held together by a powerful force, contains immense energy. This energy, locked within the bonds of the atom, is the key to understanding nuclear weapons. The process that unleashes the energy within the atom is called nuclear fission. Imagine splitting a log of wood. You release the energy stored within its chemical bonds. Fission is similar, but instead of splitting wood, we split atoms. In a fission reaction, a neutron strikes the nucleus of a heavy atom, like uranium or plutonium. This impact causes the atom to split into 2 smaller atoms, releasing a tremendous amount of energy. This energy is released in the form of heat, light, and radiation. But here's the crucial part. The splitting of the atom also releases additional neutrons. These neutrons can then strike other atoms, triggering a chain reaction. The atomic bomb, the first type of nuclear weapon ever used, harnesses the power of uncontrolled nuclear fission. Picture a domino effect, but on an atomic scale. At the heart of an atomic bomb lies a critical mass of fissile material, usually uranium-235 or plutonium-239. This material is carefully arranged to ensure a rapid and uncontrolled chain reaction. When the bomb is detonated, a conventional explosive compresses the fissile material, bringing it to a supercritical state. This triggers the chain reaction with an unimaginable release of energy. The result is a blinding flash of light, a deafening roar, and a shockwave that can level entire cities. The heat generated is so intense that it vaporizes everything in its immediate vicinity. Section 5. Fusion, the power of the stars. If fission is about splitting atoms, fusion is about combining them. Fusion is the process that powers the sun and other stars. It involves fusing together light atoms like isotopes of hydrogen. Imagine 2 droplets of water merging to form a larger drop. In fusion, the nuclei of 2 light atoms combine to form a heavier nucleus. This process releases even more energy than fission. The most common fusion reaction involves fusing deuterium and tritium, 2 isotopes of hydrogen. These isotopes are relatively abundant and easier to fuse than other elements. However, achieving fusion requires immense temperatures and pressures, conditions found naturally only in the cores of stars. This is why fusion bombs are far more complex than atomic bombs. Section 6. The hydrogen bomb, a weapon of unparalleled power. The hydrogen bomb, also known as a thermonuclear bomb, utilizes the power of nuclear fusion. It's a weapon of terrifying destructive capability, far exceeding the power of atomic bombs. Here's how it works. First, a fission bomb, similar to the one described earlier, is detonated. This creates the extreme temperatures and pressures necessary for fusion. This fission explosion then triggers a secondary fusion reaction, where deuterium and tritium atoms fuse to form helium, releasing an immense amount of energy. The result is a detonation many times more powerful than an atomic bomb. The largest hydrogen bomb ever tested, the Tsar Bomba, had an explosive yield equivalent to 50 megatons of TNT. Section 7. The Manhattan Project. A race against time. The development of nuclear weapons was a turning point in human history. It all began in the 1930s with the discovery of nuclear fission. Scientists realized the potential for creating weapons of unimaginable power. With the outbreak of World War II, the United States, fearing that Nazi Germany might develop the bomb first, launched the Manhattan Project in 1939. This top-secret program brought together some of the brightest minds in physics, engineering, and chemistry. Working tirelessly in secret laboratories across the country, these scientists raced against time to unlock the secrets of the atom. The pressure was immense, the stakes higher than ever before. The culmination of their efforts came on July 16, 1945, with the Trinity test, the first successful detonation of an atomic bomb. The world would never be the same. Section 8. Hiroshima and Nagasaki. A stark reminder. Just weeks after the Trinity test, the United States dropped atomic bombs on the Japanese cities of Hiroshima and Nagasaki. This marked a pivotal moment in human history, showcasing the terrifying power of nuclear weapons. On August 6, 1945, an atomic bomb, nicknamed Little Boy, was dropped on Hiroshima. The devastation was unimaginable, with the city being reduced to rubble in an instant. The bomb, with an explosive yield equivalent to 15,000 tons of TNT, instantly killed an estimated 80,000 people. The sheer scale of destruction was unprecedented, leaving the world in shock. Thousands more would die in the days, weeks, and years that followed from radiation poisoning. The long-term effects of the radiation exposure caused immense suffering and highlighted the catastrophic consequences of nuclear warfare. 3 days later, on August 9th, a second atomic bomb, Fat Man, was dropped on Nagasaki, killing an estimated 40,000 people. The city faced a similar fate as Hiroshima, with widespread destruction and loss of life. The use of these weapons brought a swift end to World War II but left an indelible mark on the human psyche. The bombings forced Japan to surrender, effectively ending the war, but at an unimaginable human cost. The bombings of Hiroshima and Nagasaki remain a stark reminder of the devastating consequences of nuclear weapons. They serve as a powerful lesson on the destructive potential of human conflict and the need for peace. The images of the mushroom clouds and the stories of the survivors serve as a chilling testament to the horrors of nuclear war. These memories continue to resonate, urging future generations to strive for a world free of nuclear weapons and to remember the profound impact of these tragic events. Section 9. The Cold War, a Nuclear Standoff. The decades following World War II were marked by the Cold War, a period of intense geopolitical tension between the United States and the Soviet Union. This era was characterized by a constant struggle for global influence and power, with both nations vying to spread their ideologies and political systems across the world. Both superpowers amassed vast nuclear arsenals, each capable of destroying the other many times over. The sheer scale of these arsenals was staggering, with thousands of warheads ready to be launched at a moment's notice. Submarines, missile silos, and strategic bombers were all part of this deadly equation. The world watched in fear as the two superpowers engaged in a dangerous arms race, developing ever more powerful and sophisticated nuclear weapons. Each new development brought with it a fresh wave of anxiety as the potential for catastrophic destruction grew ever larger. The arms race was not just about numbers, but also about technological superiority. The threat of nuclear annihilation loomed large, casting a long shadow over the world. Propaganda on both sides fueled the fear, with images of mushroom clouds and dire warnings of the enemy's capabilities. The possibility of a nuclear war was a constant presence in the minds of people around the globe. The Cuban Missile Crisis of 1962 brought the world to the brink of nuclear war. This was a pivotal moment in the Cold War, where the stakes were higher than ever before. The discovery of Soviet missiles in Cuba was a direct threat to the United States, and the response had to be swift and decisive. The discovery of Soviet nuclear missiles in Cuba, just 90 miles from the US mainland, sparked a tense 13-day standoff between the two superpowers. The US imposed a naval blockade around Cuba, demanding the removal of the missiles. The world held its breath as the two sides engaged in a high-stakes game of brinkmanship. Fortunately, diplomacy prevailed and the crisis was averted. Through intense negotiations, an agreement was reached that saw the removal of the missiles from Cuba in exchange for a US pledge not to invade the island, and the secret removal of US missiles from Turkey. This resolution was a testament to the power of diplomacy and the importance of communication in averting disaster. But the world breathed a collective sigh of relief, acutely aware of how close it had come to nuclear Armageddon. The Cuban Missile Crisis served as a stark reminder of the fragility of peace and the ever-present danger of nuclear conflict. It underscored the need for continued vigilance and the pursuit of peaceful solutions in a world where the stakes could not be higher.